Imagine a world where the familiar pull beneath your feet suddenly slackened, not vanished entirely, but simply halved. What if one day the gravitational acceleration we experience on Earth, that constant 9.8 meters per second squared, became a mere 4.9? This isn't about the Earth losing half its mass or the universal gravitational constant changing. Instead, let's consider a localized, hypothetical scenario where the effect of gravity on our planet's surface is precisely half of what it is today. This thought experiment opens a fascinating window into the fundamental forces shaping our existence. The most immediate and noticeable change would be your weight. Everything would feel half as heavy. A 150-pound person would suddenly weigh 75 pounds. This isn't just a feeling, it's a measurable reduction in the force pulling you down. Jumping would become an entirely new experience. You could leap twice as high and stay airborne for twice as long. Falling would also be slower, giving you more time to react, though the impact would still be significant. Objects would be easier to lift and move. Construction workers could handle heavier beams, and athletes could set incredible new records in high jump and long jump. Everyday tasks like carrying groceries would feel effortless. Our bodies are exquisitely adapted to Earth's current gravity. Having it would trigger profound biological shifts. Our bones, currently dense and strong to withstand constant compression, might become less robust over generations. Muscles, no longer needing to work as hard against gravity, could atrophy or evolve to be leaner. The cardiovascular system, which currently pumps blood against a significant gravitational pull, would face less resistance, potentially leading to lower blood pressure and different heart structures. Plants would also respond dramatically. Trees could grow much taller, their trunks needing less strength to support their weight. Root systems might become less extensive as the need for anchoring against strong winds and gravity diminishes. Gravity plays a crucial role in holding our atmosphere close to the planet. With half the pull, the atmosphere would expand, becoming less dense at lower altitudes and extending further into space. This expansion could lead to a slight drop in surface atmospheric pressure. Weather patterns would be significantly altered. Less dense air means less resistance, so winds could become much faster and more powerful. Storm systems might grow larger and move more rapidly, potentially leading to more extreme weather events. The dynamics of cloud formation and precipitation would also change. Water droplets and ice crystals would fall more slowly, potentially leading to different types of rainfall or snow. The entire atmospheric circulation system would need to rebalance. Our oceans, vast bodies of water, also subject to gravity's influence. With half the gravitational pull, ocean levels might slightly rise as the water expands to fill the less constrained basin. The pressure at the bottom of the ocean would also decrease. Tidal forces, primarily driven by the moon's gravity, would become more pronounced relative to Earth's own pull on its water. This could lead to higher high tides and lower low tides, creating more extreme coastal environments and impacting marine ecosystems. The stability of ice sheets and glaciers could also be affected. With less gravitational compression, they might become more prone to calving and melting, contributing to further sea level changes over long periods. The Earth's internal structure and geological processes are also influenced by gravity. The immense pressure within the Earth, which drives plate tectonics and volcanic activity, would be reduced. This could have complex and unpredictable effects. Plate movements might slow down or change their dynamics, potentially altering the frequency and intensity of earthquakes and volcanic eruptions. The very shape of the Earth, a slightly oblate spheroid due to its rotation and gravity, might subtly change. The stability of mountains and geological formations could also be affected. Less downward pressure might make them more susceptible to erosion or collapse over geological timescales, reshaping the planet's surface. Human society would undergo a radical transformation. Architecture would be revolutionized, buildings could be taller, lighter, and more daring in their designs. Bridges could span greater distances with less material. Transportation would be fundamentally different. Cars would have less traction, requiring new tire designs and driving techniques. Airplanes would need less lift, potentially leading to more fuel-efficient or faster travel. Space launches would become significantly easier and cheaper. Sports would be redefined. New records would be set in nearly every discipline, from weightlifting to gymnastics. Even everyday activities like walking and running would feel different, requiring adjustments to our gait and balance. Over centuries, the cumulative effects of halved gravity would reshape our world. Ecosystems would adapt, with new species evolving to thrive in the altered conditions. Human culture, technology, and even our physical forms would reflect this profound change. The very concept of up and down would remain, but its intensity would be diminished, leading to a subtle yet pervasive shift in our perception of the world. This thought experiment underscores how deeply gravity is interwoven with every aspect of our planet and our lives. It reminds us that the seemingly constant forces of nature are precisely tuned, and even a small alteration could lead to a cascade of extraordinary and unexpected consequences. Our familiar world as we know it is a delicate balance,